All right, this is AP Calculus, lesson 3-8. We are on analytic analysis. This is our lesson of the unit. So we're talking about the last part of analytic analysis where f, the function is concave up, where the function is concave down, and where I have my inflection point on my function. So the last 2 days, 3-6 and 3-7, we've been talking about the f prime test. Today we're talking about the f double prime test. This is our last test. So before we move on with the lesson, where are we in our unit guide? We are right at the end. We are on 3-8 at the bottom, analytic analysis for power standard I. So the f double prime test means I not only need to do f prime, but I need to take the derivative again to get f double prime. So let's practice taking the derivative. Derivative of my f is what?
3x squared.
3x squared
Plus 4x.
plus 4x. Perfect.
Yeah, never mind.
So f double prime, when I take the double derivative of my original function, I get what?
6x.
Plus 4.
Plus 4. There it
Oh,
is.
so you're like doing the derivative of the derivative.
Derivative of the derivative, yeah.
Oh, okay.
All right, so same steps as before. So all of this is now review. We're going to make our line, our x-axis. So there's our x-axis. And we're going to come back and we're going to make our little tick mark. Oh, before we even do that, we have to find where our critical values are. So critical values, what happens at critical values? Just a little bit of review. Critical values,
Or D and E.
it's where what equals that?
F prime.
F prime equals 0 or D and E. So let's find that. We don't have a fraction, so we don't have to worry about D and E. So now I'm just going to set this F prime equals 0. So 0 is equal to 3x squared plus 4x. All right. So how do I solve this? How do I solve for x?
So you don't do the F double derivative?
Not yet, because I'm still doing, right now I'm just doing F prime test.
Wait, then you're not setting both? Oh, never mind.
I will eventually.
No, but like, you know how like you said to set like 3x squared equal to 0 and then 4x?
I only do that when I have multiplication. That's the zero product property.
Yeah, okay.
Yeah, but we want to use that, right? So how do we get this into something times something? How do we factor this?
Would it be x?
Yep, x times
3x?
Parentheses. Plus 4.
Plus 4. There it is. I factored out an x. All right. Zero product property means I'm setting one thing equals 0 and the other thing equals 0. So I can say
X equals 0.
x equals 0. That came down from our x. And then we have 3x plus 4 equals 0 from this guy. So this is really an or. This equals 0 or this equals 0 or both. So therefore, x is also equal to negative 4/3. All right. What do I do now? This is still F prime test. Yeah, on the number line, CV. So I have a CV here at negative 4/3 and a CV here. CV, what does that stand for again? Critical value, perfect. All right. So I have my critical value set up. Now I'm going to find some test points. What's a good test point to the left of my negative 4/3?
2.
Close.
3.
1 and 1/2.
1.
How about negative?
Negative 2. Negative 2.
Negative 2. That's a good value.
Okay.
What about in between here? In between 0 and negative 4/3, what's a good value to choose?
One.
Negative 1. And what about over here?
1.
I like them. Okay. Same ones I would have used. So when I plug in a negative 2 into the derivative, now we have to be careful about which one we're plugging into. When we plug in negative 2 into the derivative, what do we get? And maybe it's better to plug it into our factored form.
So you're still not using the double derivative?
Still not using double derivative. We haven't used the black function here yet. So plugging into my f prime, what do I get? A positive or a negative?
You get a positive.
I get a positive because I have a negative 6 plus 4. This is going to be a negative 2. A negative 2 times a negative 2 is a positive. What happens when I plug in a negative 1? Do I get a positive or a negative?
Negative.
Negative.
I get a negative because I have a negative 1 out front, and this is all positive because a negative 3 plus 4 is a positive 1. So this is a negative times a positive, a negative. And when I plug in 1, what are you going to guess we're going to get? Yeah, you're right in thinking it's a positive. We don't have any absolute value. We don't have anything squared. Everything in here is positive times a positive. All right, so let's label this. This is increasing. This is going to be what?
Decreasing.
Decreasing. And finally, this interval to the right is
Increase.
increasing.
Increase to decrease is min.
Increase to decrease is a max because I was increasing and then all of a sudden I have now decreased. I was increasing and now I'm decreasing. So that's going to be a max.
Oh, that kind of does make sense because like you reach the maximum as it like goes up and then.
Right.
Okay.
Okay. Oh god.
Now we're using the double. Now we're doing the f double prime test.
Oh god.
So now we're going to go ahead and figure out these things: concave up, concave down, and inflection point.
Wait, so we don't have to label min or max?
Oh yeah, we still have to do that. Sorry, I forgot about that.
She's like, okay.
All right, so min and max. So this thing is going to be max, we said.
Yeah.
And when I have a decreasing, it was decreasing coming down, and then suddenly it's increasing. That's going to be a
Min.
min. Yeah.
Min.
All right, so this is all the stuff that we did in 3-7. This is review. Now we're doing the new stuff. So now we're going to find where our inflection point is. Why do we?
Below this now, find inflection.
What is the definition of inflection point?
Where slope equals 0.
Nope.
Where slope changes.
It's, slope is the wrong word here.
F
Not quite.
height.
Nope.
Okay, whatever.
Keep trying. Ah, there it is. F double prime. What do we know about F double prime for inflection point? Inflection point. What is the definition?
Doesn't mean you have to yell at us.
F
That
d-
it changes from one side to another.
Yeah, so the definition of inflection point, maybe we should write this on the side.
It was so. Yeah. It's like you have really soft.
Inflection point is where there's an F double prime sign change.
I just noticed that.
What's F double prime mean again? What is that?
That's the second derivative. That's over here.
So wait, but like, is that height, slope? What
It
is
depends on what graph I'm giving you. If I gave you a graph of F, then it's concavity. If I gave you a graph of F prime, what would it be?
Okay, so I still haven't
Height.
gotten that yet.
Height is whatever it's equal to. It would be
I
slope.
feel like we should have a review day on that.
Yeah, that's what I was gonna say. Like after school, like I was gonna come in, but like. Yeah.
Well, we
Dr.
have
Akio-
review days all day next week.
Yeah.
Oh
but-
yeah, that's true. Cause I feel like I get everything except for that whole like slope height thing like that.
Right. Okay. Yeah, we can talk about that next week when we're going over our self checks. All right. So F double prime sign change. So what is the? There's only two possibilities that can give us a sign change. What happens at F double prime that can give us a sign change?
The concavity changes.
So yes, that is the right idea. But maybe I should ask this question a little bit differently. So up here, when we had a relative extrema, what did F prime have to be?
The derivative of f max.
Where could a relative extrema happen? Where could it occur?
And
When it's
the slope changed.
when it's from negative to positive.
That is the definition. I agree, Carly.
Value.
It can only occur at a critical value. That's why we wanted to find critical values to begin with. We found the critical values, and then there was a potential for there to be a relative extrema. Similarly, we need to look for an F prime sign change where F double prime is equal to 0. So I'll write that down here. Inflection point, potentially where double prime equals 0. All right. So we need to find where f double prime is equal to 0, similarly to how we found f prime is equal to 0, because that might be an inflection point. So let's go ahead and do that. I'm going to do that. I should have moved everything down a little bit. I'm going to do this down here
Why is it might?
because it might not change signs. It might go from a positive to a positive, and it won't be an inflection point. Or it might go from a negative to a negative. All right, so I'm plugging in 0 for f double prime. 0 is equal to 6x plus 4. Therefore, where is our potential inflection point candidate at x equals what? X equals, come on girls,
Negative 2 over 3.
negative 2/3. Yes. And can we tell just by looking at our equation, is this going to change? Is this going to be an inflection point?
Yeah.
Joy says yes.
Wait.
Again, I'll ask the question.
No.
Wait.
At x equals negative 2/3, am I going to change from a positive to a negative? If I plug in something to the left, if I plug in negative 5, is this going to be negative? If I plug in something right, if I plug in 0, is that going to be another sign, a different sign?
Yeah.
It is going to be an inflection point. So let's go ahead and mark that then. So this is the only exception to the rule of tick marks. So I can have another tick mark here for inflection point. And I'm going to do it in a different color. This guy, maybe I should move the decreasing a little bit to the left. I didn't grab the D. All right. So this is going to be inflection point, and I'll label that IP. The inflection point is at, and it's not at negative 1. Maybe I should move the negative 1 over as well. Come on.
Okay.
I'm glad we can all be mature in this class. So, inflection point, what was the value right here?
Negative 2/3.
Negative 2/3.
Wait, answers no, I can't see.
And then I need points to the left and right to test concavity. I can use negative 1 again. Negative 1 is to the left. And I need to use something to the right. And I could use this one. That's to the right. Anything to the right could work. I'm just going to the left and right of the inflection point. So I'm just going to use the negative 1. I could have used any point to the left. I could have used negative 2 or negative 4/3. Is this negative 1? Is that going to give us a negative or a positive value for our inflection point?
Wait, so how would you?
It's gonna give negative.
I'm plugging in negative 1 into my f double prime.
It'll be negative.
Negative. Therefore, is it going to be concave up or concave down?
Concave down.
So I'm going to label this concave down.
So on f double prime, we're solving for concavity, not slope.
Exactly.
Oh.
We're assuming everything here is being given on the graph of f. All right. Now that I have 1 as my test point, I could have used 0. It doesn't really matter. Let's use 0 just to not get confused. If I plug in 0, am I going to get a positive or a negative?
Positive.
Is that going to be concave up or concave down? Concave up.
Wait, can you explain it one more time?
All right, so after I've done the first derivative test, that was everything up to minimum and maximum, these two values, then I needed to figure out my concave up, my concave down, and inflection point. The way that I do that is with the double prime test, f double prime.
Okay.
So the way that we do that is we plugged 0 into f double prime because that's potentially where we can have an inflection point. We found that that inflection point is at x equals negative 2/3. We marked that with a tick mark. And then we needed a test point on the left, a test point on the right. It didn't matter which point. If it was a negative value, when we plug in a point over here and we get a negative value for f double prime, that's going to be concave down. If we plug in a point on the right and it was positive, that was the case for our example, then that's concave up because it's a positive value.
Okay.
What did you
That
plug
makes
in
sense.
-1 and 0 into?
So can
into
I-
F double prime. Yeah.
Can you write that
Can
on
we
the
write
side,
that?
like
Yeah.
Write what down?
concave up is,
Plug 2 test points into F double prime.
and then when you get concave down, it's because it's negative.
All right, so we plugged in test points on sides of our inflection point. So we chose a point on the left, chose a point on the right. And then from there, we plugged those values into F prime. So plug into F prime, or F double prime, sorry. Plug into
You guys need me like focus like pomegranate.
F double
And then
prime.
like your bed.
I just hear your nose.
It's like
A positive value means it's concave up. A negative value means what?
Concave down.
Exactly.
It's so loud. I can't believe you guys can't hear that.
I can't hear it.
So when I give you the homework tonight, we are doing the F prime test and the F double prime test. I did both of them here. Maybe that was a little bit confusing, but you have to mark this whole number line for X up in order to find all these points. So I can squeeze this in here, I think, a little bit. I need to find, I just want to ask, where is F concave up? You guys will tell me the interval. Where is F concave down? Come on now, down. And where is my inflection point? We already know where F is increasing and decreasing. I feel that we have enough practice. I need to know these values.
So we have to solve for everything and then do the F prime test, F double prime test.
Yes. So do all of F prime test, which is everything that we've learned up to today. So the homework from yesterday and the day before that, that was all F prime test. So do all of that first, and then do F double prime test by doing this part where I set this equal to 0, find inflection point, test values, figure out concave up, concave down.
She's Peter Pans.
So give me the interval where F is concave up.
Concave up. 0.
Where does it start?
Negative 2/3 to infinity.
Oh.
Negative 2/3 to infinity is correct. All right.
It's like you shaved her head.
So I think Joey knows the rest of these. I'm going to make sure someone else speaks now. Where is F concave down? Someone new.
Would be negative infinity.
Negative infinity to
To negative 2/3.
perfect.
Or, oh yeah, because the IP is negative 2/3.
Exactly. And where is F IP, Kaylin? What do I write here exactly?
Negative X equals negative 2/3.
There it is. X equals negative 2/3. Perfect. That's all I have for you today. I can give you a trick that I have gone over in the homework, but I haven't been very explicit in terms of having it in our notes. And it's tricks with E. Do we want to talk about where E is positive and negative?
Yes.
I thought it was always positive no matter
Yeah, and I taught you guys on the side, but I haven't addressed it with everyone.
Okay,
So I want to address it now.
I'm ready.
Okay, so let's call this section Tricks with E. I want to use blue. I probably should have gone over this yesterday. Tricks with E. Or technically any number, but E. So let's say we have E to the power of X. If we plug in five, what's going to happen? If we plug in 5, so 5 is going to go, oh, my pen is a little bit hard to control here. If I plug in 5 into X, we get what? What do we get? Just plug it in, girls. E to the 5, exactly. Is this positive or negative? Positive. What happens if we plug in negative 10. What do we get?
Positive.
E to the negative 10, which is also a positive. Why is that a positive?
Because it's an even number.
Uh,
It's because it just goes down onto the denominator.
It goes to the denominator, exactly. So this is the same thing. So e to the negative 10, I ran out of room, so I'm rewriting it, is equal to 1 over e to the 10, which is still positive. Which means if the sign in front of the e is positive, there's an invisible positive sign, I guess. This thing is always going to be positive. So we can make that in red here, I guess. This thing is always positive. Is always positive. What if I did something like this? What if I had a negative e to the x? What do we know about this value?
It's always negative.
It's always negative, exactly. This thing is always negative. There's nothing I can do plugging in an x that will get rid of this minus sign. All right, cool. And not only that, I guess another key thing to be here. Neither of these two examples, neither can equal 0. They will never, ever be 0. They will always stay positive, always stay negative. They will never hit 0. So when you're using the zero product property, don't even worry about this guy because it can never equal 0. Worry about everything else. All right, that's the trick. We're all good?
Yep.
All right, let's write our summaries. You guys want to say goodbye to the invisible class?
Bye, invisible